Lesson 5-4, multiplying and dividing with monomials. So first we need to understand what exponential notation is. We have a and a b. The small b is the exponent and the a is called the base. Exponents are also called powers. They represent repeated multiplication. So for example, 3 to the 4th, 2 to the 6th, or 5 to the 3rd, 3 to the 4th is 3 times 3 times 3 times 3, 4 times. It is not 3 times 4. And that's a very common mistake that someone will make, is they might say 3 times 4, but that's not what this is. 3 to the 4th, again, is 3 times 3 times 3 times 3, which is 81. 2 to the 6th is 6 2's being multiplied, and that's 64. 5 to the 3rd is 3 5's, so that's 125. It is not 5 times 3, which would be 15. They're very different. Well, when we multiply monomials, we use the property of multiplying exponents with common bases. Now, if you remember, in our first example, a was our base. So if we have a common base and we multiply, we add the exponents. Okay, here's how this works. X to the 5th times x to the 8th is 5x's. That's x to the 5th, and x to the 8th. Oops, I came one less x. Should be 8. Okay, so x to the 5th is 5x's, and x to the 8th is 8x's, and they're all being multiplied together. So all together, I have 13 x's, or x to the 13th. Well, I can skip writing all of this out if I just say x to the 5th times x to the 8th is x to the 5 plus 8, which gives me 13. So here I have x to the 4th, and x squared is x to the 4 plus 2, which gives me x to the 6th. If I have more than one variable, or I have coefficients, I multiply the like terms. So, 3 and 6 are like terms, so I'll multiply those. 3 times 6 is 18. X squared times x to the 3rd is going to be x to the 2 plus 3. And y times y squared is going to be y to the 1. Don't forget there's an invisible 1 there, plus 2. So that's 18 x to the 5th, y to the 3rd. So here are some more examples. 2 times 3 gives me 6. There's a 1 here, so I have 1 plus 2 is 3. 2 times 6 is 12. There are no other x's, so that just carries over. And then 1 plus 3 is 4. 4 times 2 is 8. 2 plus 4 is 6. 2 plus 4 is 6 again. So what I would like you to do is I would like you to pause the video and try these 3 examples. As you can see, they're very similar to the 3 that I just did. And multiply the coefficients, add the exponents. When you've finished, come back and check your work. Okay, so 3 times 4 is 12. 2 plus 4 is 6. Here I have 5 times 6 is 30. 3 plus 2 is 5, and 2 plus 1 is 3. 6 times 7 is 42. 4 plus 2 is 6, and 3 plus 3 is 6. Now when we divide monomials, we use the property of dividing exponents with common bases. Now remember, multiplication and division are inverse operations. That means they're the opposite of each other. So from there you might be able to hypothesize if when you multiply exponents with common bases, you add the exponents, what you would do when you divide. We subtract the exponents. So here I have two examples, and I'm going to again show how this works. If I have 9x's and 3x's, anytime I divide x divided by x, that's 1. So these will all cancel each other out, and I have 6x's left. Well, I could do 9 minus 6. And that gives me 9 minus 3. And that gives me x to the 6th. When I have a higher exponent in the denominator, I still cancel. These two will cancel. That leaves me a 1 in the numerator, and I have 8 x's in the bottom. The other way we can do this is we can think of it kind of as a tug of war. Or you can use the property of negative exponents. X to the 2 minus 10 is equal to x to the negative 8, and we don't allow negative exponents, so we put it in the basement. The other way you can think of it as whichever one is bigger wins the tug of war. 10 was bigger, so the 8 ended up on the bottom. If you have more than one variable or have coefficients, you divide the like terms. 18 divided by 3 is 6. 18 is larger, so the 6 is on the numerator. 12 minus 5 is 7. 12 is larger, so the 7 is in the numerator. 9 minus 1 is 8, but the 9 is larger, so the 8 is in the denominator. Here are some more examples. I have 4 over 2, that gives me 2. 2 minus 1 is 1. 8 over 2 is 4. 4 minus 2 is 2. And then I have a y that stays in the denominator. 10 divided by 5 is 2, but because the 10 was in the denominator, it stays in the denominator. 10 minus 5 is 5. 16 and 20 don't divide evenly, but they do both divide by 4. So I get 4 and 5. I have an x to the 3rd and x to the 5th. 5 minus 3 is 2, and that stays in the denominator, and then a y in the numerator. So what I would like you to do is pause the video and try these 4, and then when you're finished, unpause the video and check your work. Okay, so 5 minus 1 was 4. 3 and 18 gave me the 6 in the denominator. 3 minus 1 is 2 in the denominator. 2 minus 1 is 1 in the numerator. 12 goes into 24 2 times in the denominator. 2 goes into 6 3 times in the denominator. The x is by itself. And then 6 minus 2 is 4. 18 and 24 both divide by 6, giving me 3 and 4. 2 minus 2 cancel each other out. It's 0. They go away. 4 minus 3 is 1.